What I have here today is a project using a servo motor and temperature sensor for my electrical engineering class at GHS. What it does is read the temperature value in degrees with the TMP36 sensor, and it uses that value for the angle of the servo motor, which is indicated by the paper dial. The servo motor is different from a normal motor because you can specify a specific angle and it'll go to there exactly, and attempts to hold that position even when something like your finger is pushing on it. This is great for what I'm doing because I can give it the exact value and it'll stay there until the temperature changes. The temperature sensor works by being basically just a transistor or two diodes. Normally, a transistor is used for things like logic or logic gates, but in this application, it's modified to read and output the voltage drop between the two pins, the emitter, and the base. The voltage drop decreases at a known rate while the temperature decreases, which means that the analog signal it produces is proportional to the temperature. So this will let me just use a little math in my code to get the real life temperature from that number it puts out. So you can see here the setup I have for my project. On the left I have a dial with a servo motor controlling it, and that is connected to my ESP32 with a temp sensor also connected. Here you can see the output pins for the analog and the input pins for the analog that are connected to the temperature sensor and the servo. You can see that when I put my hand on the temperature sensor, the servo motor begins to move to indicate the higher temperature. It slowly starts to flicker up to around 75 or 77 degrees, and as soon as I remove my hand, it begins to go back down to around 65 or 67, which is room temperature in this room. For this project, I decided to use my personal ESP32 board instead of the one that's provided by my school, which is Arduino. The ESP32 is pretty similar capabilities to most Arduino boards, but it also can connect with Bluetooth and Wi-Fi, as well as having a few more pin connections. But because it's a completely different board, this will cause the code to be a little different. But the wiring is decently simple. I just have 3 pins for the temperature sensor and also 3 pins for the servo. For the servo, it is the power, ground, and signal, and for the temperature sensor, it is the power, ground, and also the sensor output. These are all just connected to the analog inputs and outputs, 5 volt and ground, for the ESP32 board. For this code, I had to use a library so that the servo motor would work. So at the top, I have to use this right here. That basically just tells the program to use the coding library for the servo for this specific ESP32 board. And also for this library, I will declare the name of the servo, which we'll use also down here. This right here is just saying which pin that the motor is connected to, and this is creating the variable for temperature, which will be used later. The rest of the setup code is just stating the default values of the servo motor to the library, as well as just beginning the serial monitor to check the variable values. Inside the main loop right here is the important part of code, which will set the temperature variable, which is this line right here. Takes the analog reading from the temperature sensor, which is this analog reading pin 32, and divides it by 10 after subtracting 20 from it. I found this formula because I had another thermometer in my room that was always saying 65 degrees, and my value was always around 670. I checked this by using a couple of other thermometers I had around my house, and they all said around 65, so it was decently accurate. Next, in the code, I'll just send this temperature value to the servo, which will set it to that angle. This right here will just print the temperature value to the serial monitor. And this right here, I included a 1 second delay. This number is in milliseconds, so it's just 1 second. And that'll prevent constant flickering of the motor. It's because the value isn't exactly stable, and it was constantly going up and down by 1 degree, and that was causing the motor to go back and forth very fast, and that was not fun to deal with. Here I have my schematic open inside the KiCad program, and what it has is basically just the ESP32, my temperature sensor, and the servo motor. And you can see that the positive and the VDD, which is also just means positive, are connected to the voltage output of the ESP32, and then the negative or ground for both of these is coming to the same spot, the ground on the ESP. Here you can see that the analog output is going to the analog input of the servo, so that way it can receive the value from the code, which was also given to it by the temperature sensor, which is sent out through the Vout pin, follows that wire, and goes to the IO32 analog input, which is received as a value that's between 0 and 1032. And the code would basically just convert it to a real degree value and send it back to this servo. So all in all, this is honestly a pretty simple project in terms of the schematic and wiring, but most of the work was just in getting the temperature sensor to give a realistic value in terms of what it actually says and what the actual temperature was in the room.